This video is going to show you how to solve an example projectile motion problem. This is problem 43 on the worksheets. A dog is in the field catching a frisbee. The dog leaves the ground at 7.53 meters per second at an angle of 50 degrees with the ground to catch the frisbee at his apogee. How long was the dog in the air until he caught the frisbee? How far horizontally did the dog jump to catch to the location where he caught the frisbee? And how high did the dog jump? To begin with, we'll start with a table of givens. So our basic kinematics variables are VO, X, TV, and A, or Vox TVAs I had everyone talked about memorizing. I have two accelerations. Vertically, I have the acceleration due to gravity, and horizontally, I have an acceleration of 0. Each acceleration gets its own list of givens, so I've divided up into vertical and horizontal. So basically for this problem, I've got the ground and the dog's jumping, and he's going to catch a frisbee at apogee. So the two conditions that define this place of apogee, one is it's the highest point, and two, the vertical velocity is 0. So I'm going to use the fact that the vertical velocity 0 is one of my givens from the problem. Second part of the problem, part B, is going to talk about what the range is. And the range is just going to be over to apogee. Normally we do the total time it's in the air, but this time we're just going over to apogee. So let's start with our givens triangle before I even look at any more of the questions. I know that the dog is jumping at 7.53 meters per second. The angle is 50 degrees. So I'm going to turn this into a right triangle, start with the horizontal piece. So the horizontal initial velocity is 7.53 meters per second cosine 50. Cosine because this is the adjacent side to the angle. So I'm going to put that in my table of givens to organize my work. So 7.53 meters per second sine 50 degrees. Now that's also the same as the final velocity because the acceleration is equal to 0. Now to finish my triangle, I'll go upwards so the two tips meet. So the vertical initial velocity is 7.53 meters per second sine 50 degrees. And I'll put that in my table as the initial velocity vertically. And it's positive because it's going up. So in my table I've got gravity is negative because it's going down. I got the initial vertical velocity is positive because it's going up. Horizontally, all the information is positive and the acceleration is 0. So those two in the bottom, the accelerations, that's just a given for a table for projectile motion. Now let's start looking at the questions. Part A wanted to define the time to where the dog caught the frisbee. So time from when he left the ground to when he caught the frisbee. So I'm going to find the time with the vertical givens. So I look at my vertical givens. I need the equation with V, V naught, A, and T in it, which is the VOAD equation. Putting in my numbers from the table in the vertical column, 0, that's the velocity at apogee, is equal to 7.53 meters per second plus negative 9.8 meters per second squared. Solving this for time, I get the 0.5886 seconds. So basically 0.589 seconds to apogee. Alright, just to organize my work, I'm going to go ahead and put this in the table just so I can have it as a reference for later. Part B said to find the range, or the distance over to where the dog caught the frisbee. So that's going to find the range over to apogee. To do that, since I'm finding a horizontal distance, I'm going to use the horizontal givens only. So I look at the table. Horizontally, there's only one equation that works. That's the range is equal to Vx naught times t. So therefore, the range is equal to the horizontal velocity, 7.53 meters per second sine 33, times the horizontal or total time of the air to the apogee, which is the 0.5886 with all the decimal points. And I get the range to be 2.85 meters. Part C asks me to find the maximum height at apogee. That means I'm finding it at apogee. To do that, I'm going to use just the vertical givens because I'm talking about a vertical distance. So if I look at my givens, I can use a couple different equations, but I'm going to use the V equals V naught squared plus 2ax because that uses the givens out of the problem and not a previously calculated value. Putting in my numbers, I get 0 squared is equal to 7.53 meters per second sine 50 degrees squared plus 2 times negative 9.8 meters per second squared times x. Solving for x, I get the height to apogee, or the highest point the dog will jump to, as 1.70 meters.